Let's dive into something that could fundamentally change, well, just about everything that gets hot. I'm talking about jet engines, power plants, and anything that needs to run efficiently. It looks like a new breakthrough in material science is about to smash a decades-old temperature barrier that has held back our technology for years. Scientists in Germany have created a new super metal that can stay incredibly strong at temperatures way hotter than current materials. We're talking over 1100 Celsius because there's a kicker, but there's a kicker. Unlike other heat-proof metals, this one doesn't become brittle and shatter at room temperature. This is the holy grail for engineers, as it means we can finally build things with it, opening the doors for hyper-efficient jet engines and power plants. What do you think about this, John?
I'm excited for this. This is really cool. And one of the alloys, or one of the ingredients in this alloy we've covered before, and I can't remember why, but I just remember it because of how it's pronounced. So the new alloy, it's made from chromium, the one that we covered before, molybdenum, and a tiny amount of silicon. So this new alloy, it doesn't break, it doesn't rust, and it doesn't melt under conditions that would destroy most other metals. And so obviously this is revolutionary. The problem is that they've faced an impossible choice when designing jet engines, power turbines, or other high temperature equipment. The thing is they could use materials that are incredibly strong at high temperatures, but crack easily at room temperature, or they could use materials that are flexible and workable, but can't handle extreme heat. So this new alloy is the first to excel at both. And so this breakthrough kind of centers around three key properties that have never been achieved together before. So the first is room temperature ductility, which is unlike other super strong metals, you can bend and shape this material without it shattering. The second is extreme heat resistance, which means that it can operate safely at temperatures of up to 1100 degrees Celsius, or for your US people, 2012 Fahrenheit, and has a melting point near 2000 degrees Celsius, or 3632 degrees Fahrenheit. And the third breakthrough property is oxidation resistance. So it doesn't rust, corrode, or degrade, even when it's exposed to oxygen at scorching temperatures. So the thing about this is these implications are enormous. Every degree of temperature increase in jet engines and power turbine translate to roughly 5% better fuel efficiency. This is really cool. We can get into a whole lot more about the molecular makeup of this, but I think this is really cool. What are your thoughts on this, Craig? Do you think this is our wonder material that's going to help us with fusion technology, with these jet engines that maybe we'll cover today or maybe we'll cover in another episode?
Yeah, I think so. And I like, it says cut fuel use about 5%. That's billions in savings for airlines. And if you talk about effect on the environment, that means less pollution and stuff as well. So it'd be really a cleaner, more efficient energy and plane and power means that we burn less fuel. This directly translates to CO2 reduction. Power plants, gas, coal, and even nuclear could run more efficiently, squeezing more electricity out of the same amount of fuel, improving our energy grid. This is perfect for things like rockets and satellites that have to survive extreme heat and cold going through space and whatnot without cracking.
Yeah.
So I really love that we have this new space age material, and we'll have to see what it looks like taking it out of the lab. It worked perfectly there, but will it work in a real high pressure jet engine that's shaking violently in 10,000 hours?
Yeah, well, the cool thing, and we always talk about scalability and manufacturing, right? So the cool thing about this is that the alloy synthesis employs arc melting techniques with carefully controlled atmospheric conditions. What that does is that ensures compositional homogeneity, and it minimizes contaminations. So they've developed specific protocols for melting under sub-atmospheric argon environments with zirconium jetters to eliminate residual oxygen that could compromise the alloy's oxidation resistance properties. The manufacturing approach that they've done it actually demonstrates scalability potential through established powder metallurgy routes that are familiar to the superalloy industry. So what I like about this is that unlike exotic processing requirements that often limit laboratory breakthroughs from commercial implementation, the way that they approach this alloy's production, this aligns with existing industrial capabilities, which means this could scale soon, which I like.
Yeah, the big question is how cost effective will be, because the manufacturing process sounds incredibly expensive. They use ultra high pure materials and a complex art melting process you talked about. Involves melting the alloy 5 separate times to mix it properly. So it sounds quite intensive.
It does. Yeah, it does. And obviously this is going to be very expensive at the start until they can figure out how to manufacture it cheaper. But at least we know that it can scale, which is one of the biggest hurdles for things like this.
And the secret is a tiny amount of silicon. The whole recipe works with just 3 atomic percent silicon. Any more and the alloy becomes brittle, any less and it doesn't protect itself.
Crazy. I love it.
So this is really cool stuff. This new super metal is a huge deal, and it's at the starting line, not the finish line. It's the key that could unlock a new generation of hyper efficient, cleaner technology. We'll be watching this one closely to see if we can make the jump from the lab to the real world. That's all the time we have, but we'd love to know what you think. What's the one technology you're waiting for that could change everything? Let us know. So what do you got going on, John?
Yeah, well, just helping companies secure government funding. So, it's a great time to reach out if you have any questions. How about you, Craig?
Well, there's a lot going on over at flowgrammer.ca. We're doing automation and AI and business processes. We do events, but we're really ramping our business up. And check out all the things we're doing over there. If you're interested in business automation, we've got community events where we're teaching everyone. We do an online, and we're about to launch our new resource center, flowgrammers.ca, which might be out when some of these are out. Other than that, check out for everything we do. Our monthly startup investor drinks, where you get to pitch to the crowd, business owners and investors, and have real conversations and make real connections. So for all those things, check out torontostarts.com. And for everything else, anything else, John, before we say goodbye?
No, just reach out to me on LinkedIn, John Irwin, if you want.
John Irwin on LinkedIn. Thanks, everyone. We'll talk to you